Hi, this is Jihan, and today I'm gonna talk about the independent class, uh, which is a operator overloading. Okay, so first one, what is operator overloading in C++? So I Google searched. So in C++, we can make operators to work for user-defined classes. This means C++ has a ability to provide the operators with a special meaning for a data type. This ability is known as operator overloading. For example, we can overload um, operators plus in the class like a string or whatever, and the other example class, yeah, and the minus, divide, and the division, or right. So let's see the example, right? So they have have a class function private and public. So integer r is a real number, and the image, so I, right? So declared the function. So see the functions right here. So r real is and plus I. So C1 is a 10 and a 5, and C2 is a 2 and a 2. So C3 is equal to C1 plus C2, right? So what is a C1? C1 is R plus R1 plus R2, right? So it's a real number, two real numbers, so it's gonna be 12. And what is C2? C2 is the 5 plus 4 is a 9, but there's one more thing. Need to add I at the beginning, right? So, okay, let's go to my code and go to my code. Oh, right here. So first one, so I wrote the code is the fractions, right? So the fraction, what is the fraction? Let me draw the picture. Yes, okay. So the fraction, so I just wrote the f, right? So there's two values in the fraction. So first one is the numerator, right? And the second one is the what was the name? Oh, denominator, yeah, denominator, and numerator. The numerator is on the top. The numerator is on the top, and the denominator is at the bottom, right? So that's fraction. That's it. That is the fraction. And go to my code first. Pragma ones, and include IO stream, right? Because I have an O stream inside of the what's that? Let me clear this one. I have an O stream. So O stream is a part of the IO stream. So just basically just add the IO stream inside, and the class fraction, name the fraction class, and the private I have an integer numerator and the integer denominator, and the void the normalized. Oh, I'm gonna talk about the normalized later, okay? And the GCD is algorithm, which is kind of a math. I'm gonna talk about that later. And the integer compiler, because we have to compare each of the function, right? And the public and constructor, default constructor, and the constructor, and the another constructor for the numerator and the denominator, like divide, and the C plus, minus, and forgot the English name. Okay, never mind. And the division, and yes, and what's that? Is a greater and greater than equal to, and less than equal to, and equal to, Yeah, and this one is the pre-increment and the pre-decreasement. I'm gonna talk about this one later too. And inside of the data type, the argument, right? And that one just only for test. I'll see that later. Okay, so going to my fraction.cpp implement class, right? So let me talk about the normalized first, okay? So normalize is that called normalize? Yeah, normalize function by the first one moving sign to the numerators, and the second one is ensuring a numerator and denominator have two common divisor. So for examples, like integer the sign equal to 1 means the sign is a positive, right? Let me do it together. Yeah. So let me see. So if integer is equal to 1, right? No, for the sign equal to 1 means that's a positive number, right? And if numerator is smaller than 0, means that the sign is equal to negative, right? Let me draw the line. So for example, like -1 and divided by maybe x. So what is the sign? Sign is equal to minus, right? So that's the sign does. And if the denominator smaller than 0 and the sign equal to negative sign, so just flip it up. For example, just like that. If either one is negative, so just for the function it's gonna be negative. And assert function, yeah, we need to include the C assert library, right? And the assert dominator is now equal to 0. Integer d is equal to 1. That's logic. And if numerator greater than 0, d equal to GCD numerator denominator, right? And the numerator equal to sign times numerator divided by d. That's the GCD algorithm, the math. Let's see. GCD, yeah, what is a GCD? So GCD in mathematics, the greatest common divisor, called GCD, of two or more integers which are not all 0. Is the largest positive integer that divides each of the integers. For two integers x and y, the greatest common divisor of x and y is denoted. For example, so GCD of 8 and 12 is 4, right? So yeah, just find the common numbers, right? See that picture too. The 20 it's a GCD 24 and 18. So 24 is a 2 times 2 times 2 times 3. So the common number is a 2 and the 3, right? So the 18 is a 2 times 3 times 3. So they have a 2. The one common number is 2. The second one is a 3. So 2 times 3 is equal to 6, right? So this totally mathematics. So we have to understand, right? So third same, right? So yes, that's mathematics. And see what I got it later. Also the compile, and yeah, this is all constructors. We set up the value n, right? And this one set up the value n and the d, numerators n and denominators d, different constructors. And normalize. Don't forget to normalize. Just like we did the assignment in the class, just like a compare size, right? It's the same thing actually. And see the return numerator and the return denominator, yes. And that's the plus sign. Oh, where's compare is right here. Let me find the compare first. Yeah, let's the compare first, right? No, it's not there. Alright, just yeah. So okay, just keep going. So integer r and n equal to, that's the function, just name the r and n because numerator and the denominator is equal to numerator times right side dot denominator plus right numerator times denominator. Let's see. Yes, and the RD is the right numerator and the right denominator. Right, denominator times the right denominator is gonna be the right, and the numerator gonna be the new numerators, and the return the function. Don't forget to return the functions, right? And the minus, exactly, just copy this line and just change to the minus one. And the action fraction, the times, just basically just times. This way is more easy actually. So just the numerator times the right numerator, the denominator times the right denominator is gonna be the new one. And yes, numerator returns compare, so the return numerator times the right denominator and the minus right numerator times denominator. That's the compare. We have to normalize, right? Let's see. Yes, plus then and equal to, let's see, my main function. So I set up some values like so the first one is f1 and the second one is f2. F2 is a 3, right? But what is a 3? It means the 3 divided by 1. That means 3. So I can use the same thing like 1. But I can't because my constructor, the second constructor, just set up one value, which is the integers. So yeah, the third one is two values, two integers, right? So that means 3 plus 2 over 4 is gonna be 7 over 2. Let me debug. Start debugging. Okay, so let's start debug. Okay, and set up the breakpoint, and where's the debug mode? And see the F1, F2, F3, and ABCD, and step over. Oh no, I set up the wrong one. Let's see first here, F1 and F2, F3, right? No. How can I delete this one? Stop. And debug. Yes. So F1, F2, F3, right? Let's see. Step over. You see F2 is equal to 3. Right, let's see. F2 denominator, yeah, right. And F3. Right now, F2 is a 3 over 1, right? 3 over 1, 3 over 1. And then right now, step over. So the F3 is 2 over 4 is normalized, just 1 over 2 is mean the half, right? So step over was let's see, f1, f2, t false, numerator t false, and yeah, so f1 equal to f2 plus f3 is gonna be 7 over 2, right? 7 over 2 right here. 7 over 2, where can I find it? Can I find it? Yes. Done. And the fraction a is equal to 2 over 3, b is equal to 4 over 7, so c is equal to a minus b. Let's debug of the breakpoint. Set up here to debug, and step over. That's the a, right? Let's see a. What's the value of a? A is a 2 over 3. 2 over 3, and the b is 4 over 7. So what's gonna be c? Step over. C is equal to 2 over 21. Let's test. Is that correct or not? Okay. That's so annoying. Save. Let's see. So a minus b, right? So basically a is to 2 over 3 minus 4 over 7. So times the first one is gonna be the 21 times 7, right? So 21, 14. The second one is gonna be the 21 too. So the 14 minus 12, right? Because it's gonna be times 3, because the 7 times 3 equal to 21. So the 4 times 3 is gonna be 12. So the result is gonna be the 2 over 21, right? That means that's correct. And don't save. And C, and the step over, C is gonna be 8 over 21. So let's try. I think this is gonna be correct. We don't have to try, right? Let's just type here. It's more easy. I don't want to draw the picture. It's so complicated. So basically, the first one is gonna be 21, 14, right? 14 over 21, and divide by 12 over 21. So 12 minus 12 is gonna be the wait, let me see. So let me see. 14 over 21, 21 over 14 is gonna be 8 over 21, right? And step over, next one, it's gonna be negative a. Oh yeah, that means the negative one. This means the negative one. Step over, it's gonna be 7 over 6. Let me see. 7 over 6. So a is equal to I think something wrong here. not gonna be 7 over 6. 7 over 6. Okay. And keep going. Okay. Sub debug. So the Boolean function. So all the equal and less than and equal to, smaller than, equal to, all use Boolean function because we need to check. If are not greater than, we return false, and if greater than or equal to, we return true. Right, this is all the Boolean function we already talked about in the class. That's another one is pre-increment. In the pre-decreasement, right, we set a t and the k, right, and another one, same, the y plus plus, and try to compile. See, yes, everything works. So basically those parts just for testing every test. Let's see. Yeah, I think everything's clear, nothing left need to explain. That's, oh yeah, the O string, yeah, and that's for the C out, right? That's the C out value, and we use out, no C out only for the out functions. And yes, basically just that's it. Let's see out. Let's see the increment function y and z, right? Let's try first. WT. So y is -3 over 5, and z is equal to 2 over 5, right? Let's see what difference. So the first one, where's the y? Y is here. So the fraction y is equal to 2 over 5. That's correct. And fraction z, so declare two values. And z is equal to y plus plus. So y, z is equal to y right now, and the k is equal to y. K is equal to y plus plus is gonna be my plus 1 is gonna be 7 over 5, correct? Yes. And yes, that's it.